Hello, this is checkpoint 2.23 from section 2.4. Here we have a function. They want us to decide whether f is continuous at x is equal to 1. And if it's not continuous, what kind of discontinuity is it? So here are our criteria for continuity. If it's defined and if the limit exists and the limit is equal to the function. Now, if we have an issue with the limit, then depending if it's a one-sided limit not meeting up together, then that would be a jump discontinuity. If it goes off to infinity with the limits, then it's an infinite discontinuity. Now, if the limit does exist and it's defined but they're not equal to each other, or maybe it's not even defined, as long as the limit exists, then the limit from the left hand and right hand side is going to be going to the same point, which means the limit exists, and if it's not defined or if it's not equal to each other, then it's a removable discontinuity because you just have to redefine the function. All right, let's go through the steps here. For our function, and we want we want to figure out what happens at 1 when x is equal to 1. So if we put 1 in here, it looks like it's going to give us a value of 3. And then the second part, if we take the limit as x approaches 1 of this function, it looks like we can just use any value except for what happens exactly at 1. So this is going to be the limit as x approaches 1 of x squared. And x squared happens to be a nice polynomial, so we know we can just put 1 in. And so this is just going to be 1. And now we get to the third part, and clearly these two are not equal. So limit as x approaches 1 of f of x is not equal to f of 1. So this is not continuous. Let's do this in not continuous at x equals 1. All right, so now we've established that it's not continuous, but now we know that the limit does exist from both sides. And so since the limits exist, then we know that this is a removable discontinuity. X equals 1 is a removable discontinuity, which means you can remove the discontinuity and make it continuous by doing something else. So maybe we want to redefine f of 1 so that it's not equal to 3 but equal to what the limit is supposed to be. So redefine f of 1 to equal to 1. And that is to say that your new function f of x will equal to it's still going to be x squared when x is not equal to 1, and it will be, instead of 3, it'll be 1 when x is equal to 1. And since really this is the same thing as x squared, because that's the value of x squared when it's equal to 1. So in any case, we've identified the type of discontinuity, and then we can find a way to fix it if we wanted to. All right, I hope that helps.